Welcome to Cybersecurity Inside, live from the green room, backstage interviews with speakers who are shaping today's discussions on cybersecurity. Now, here is your host, Camille Morhart.
Hi, and welcome to today's episode of Cybersecurity Inside, live from the green room. This is Intel's Innovation Summit, and I've got with me Ria Cheruvu, who was just on stage with Pat Gelsinger, Intel's CEO. She is Intel's AI ethics lead architect. She graduated Harvard University at 14 years old and joined Intel, and a year or two after that went back and got her master's degree. She is now 18 and also Intel's AI ethics lead architect. I'm really interested in talking with her about all things ethics as they relate to artificial intelligence. So let's listen closely and find out what insight she has to give us. Welcome to the show, Ria. I have a number of different places to start, but why don't I just toss that to you and say, where would you start in a conversation about artificial intelligence and ethics?
I would definitely start off with what is AI ethics in terms of, what is the definition that we start to care about, and what does it really mean to develop technologies that are responsible and trustworthy, and why it matters.
Okay. So what I've heard is over time, there's been concerns around privacy and surveillance. If you want to put those in a category together. Concerns around bias and that even unintended bias leading to discriminatory policies or frameworks or actions taken. This is all within the context of artificial intelligence and what people worry about. And then inexplicability. So if we call it unexplainable output from artificial intelligence. And I think that people are kind of familiar with those at a high level. So are those still the major concerns, or have we moved on and there's new worries?
Definitely still the same concerns that are applicable on a wide variety of levels, and the folds at which these emerge is starting to become a lot more clear. For example, with privacy and surveillance, this started to come up when we were thinking about situations like, okay, surveillance in malls or in airports. But now we're starting to see that there might be some more downstream implications that we had previously not thought of that are opening up interesting new use cases for AI systems as well as considerations. So a great example of this is, policing workers. When you're using or applying these algorithms that are detecting hard hats or other types of objects, can they be unnecessarily or in an unanticipated way be used to police workers' time breaks because you're able to figure out when a worker is on a particular location and when they're not. So these types of downstream implications where you now start to have multiple AI principles and AI ethics principles intersecting with each other, that's the current focus as I see it today, Camille.
So it's not so much that there's new categories that we're worried about, it's that we hadn't even thought of things that we could track now. Even if we're not attempting to track them, it's like, oh, well, we now have, because when you think about the level, when you talk about privacy and then you think about precision medicine and you think about even down to gene editing, and now you're talking about a company that maybe a corporation, maybe even having access to your own personal genome, that's pretty detailed.
Exactly. And it is a little bit of both. So there are also some new categories that are emerging, like sustainability for AI systems and energy efficiency. And a lot of the conversations around there are fresh, new tooling ecosystems, new discovery of the nascent nature of overall all of the different directions that we can take, as well as the regulations and restrictions that we want to apply. But yes, it does boil down to these main categories and then all of the use cases that we can start to see this applied in. For example, just taking transparency in the healthcare domain as well, where we start to get into contentions with security, which we've always known, right? Transparency and security are always in contention with each other. But the way that we navigate that in relation now to user experience and making sure users are comfortable with the way that their data is being used, they know what's going on, but we're also able to differentiate between malicious users or attackers of the system. All of these very complex questions are really coming under the AI ethics domain and are starting to be addressed for different use cases.
I want to talk about some other kind of new, fun, troubling, it depends on your opinion or perspective, use cases that we're seeing. Like one thing is we have, I guess we would call it generative AI, where we're creating, artwork or music or all kinds of other things, videos. And well, tell us the difference between that and deepfake. Is it one and the same, or is it how you're applying it?
Uh, Not the same. So it can be different methodologies that are applied for them. The concept generally behind these can be the same, but yeah, I would definitely put it under different categories because the models composing them are different. So with generative AI and with, uh, different types of networks that are used to generate images, it is definitely the same fundamentals that we're starting to see as part of text generation and image generation models like Dolly and Clip that are out there. It has kind of spun into, in and of itself, its own motivations that we're starting to see with these models as well. But the fundamentals are shared between different disciplines and are continuing to grow.
But can you say more about generative AI? What is it generating?
Absolutely. So it can generate text, images, and audio in certain cases. It is essentially being able to digest a large database of different types of samples of the data modality of your choice, and then is able to perform essentially a reconstruction of that and then output or spit out in a sense a reconstructed version of that data point that is matching the type of input. And again, the methodologies differ based on the exact model that you're using. The overall fundamentals of this reconstruction element generally stay the same, but the more that we change it, and sometimes and in most cases the bigger we make the models, the more iterations we train it for, the better results we get.
So, in that context, AI can generate, say, news articles that could be posted that are made up by artificial intelligence.
Yes, and a colleague and I were thinking about this a couple of years ago, just thinking about, okay, what are the implications of an AI model generating news content, especially when human users and readers can't really distinguish between AI models and what a human is writing, and what are the implications of that? There's definitely the opportunity for misinformation to be propagated. I know that there is some recent uprise in, for example, students using AI models to generate their essays as well, which is starting to come into or bring into play questions like, is that a good thing? Using an AI system to handle a lot of the grunt work that you would need to kind of compile all of these references, or is it taking away from the learning process as well? But overall, there's a lot of concerns around the indistinguishability of the text that's generated or the images, but also, a lot of sight into the potential of these systems. So it's a very interesting balance that we need to tread here between the two.
I know that AI can generate like paintings of, let's say, long since deceased artists. So we're seeing what would Van Gogh be painting now if we were and generating, and it's sort of fun and interesting to look and see how good it is. But that this can cause kind of a different sort of question when it's generating artwork from living artists who are also generating artwork at the same time. How do we handle that kind of thing?
Yeah, and I think it's tied to where it's like licenses, copyrights, and how do we really navigate all of that. We had a couple of very interesting backstage conversations at Innovation on this as well. And so Camille, today I think the way that we're looking at it from an AI perspective is when you're distributing these models, there are certain obligations that you may need to follow when it comes to transparency and documentation related items. And I think that the legal perspective to that is still nascent. It does need to be integrated fairly quickly. It is amazing to be able to understand the failures and the weaknesses of the model, the provenance of the training data, and related elements. But we do also need to have some guidelines around what data that the AI model can draw from. It's not always limited to that, but I think that's a really good first step. If we're able to understand where the data the AI model is being trained on is coming from, we're able to constrain that database to the images that we know the AI model can use, or the developers of the system are able to create a model that's able to use responsibly and track that over time. I think that's a great source or a first step. But that is contingent on not releasing models that are trained on these huge corpora of data sets that are all mangled together, and we're not really able to track where they came from, and how do we provide that credibility back to the original source.
Can you talk about deep fake? What is that, and how do we distinguish it, or can we?
Deepfakes is a pretty challenging topic. So previously, and I feel like it's lost a little bit of its hype right now, which is kind of strange. The stable diffusion and generative AI part has taken the focus, I think, as part of the media. But deepfakes are always a constant concern because you have AI systems that are able to generate images, video, and audio that's pretty much indistinguishable to what you would expect to see in the real world, narrated by a human or by nature. And the interesting thing with deepfakes is the number of different use cases that they could be used for. I feel like the technology between these elements, as well as the elements that we might start to see with, for example, image reconstruction, where you're actually bringing old images, in like black and white style to life. You're able to color them and then to create 3D reconstructions. There's a lot of interesting potential there, and for me, I feel like deepfakes is kind of the opposite side of that, where there may be some potentially good use cases in education, but we're seeing a lot of the opportunities to promote misinformation with this technology. How do we control it? Are we creating AI models to be able to detect deepfakes that are produced by other AI models? Is it some sort of a competition in order to figure out, who is generating what, and then be able to thwart that immediately? Are there ways that we can use traditional computer science and cryptography and hashing in order to figure that out? I think those are conversations that are still ongoing. Again, the focus I feel has waned a little bit, but it's going to rise back up very quickly as we see more efficient creation of deepfakes and hopefully more efficient creation of detectors and thwarters in that space.
The other phrase you brought up is stable diffusion. Can you describe what that is?
So stable diffusion is one of these, image generation models that's very big out there. It's getting integrated into a bunch of different applications, and I believe it is what is powering a lot of the current kind of websites and services that are out there. And I'm still getting a grasp of the technology and reading through the articles. I mean, can you believe it? It's popped up within like 2 months. All over the place now. We see the words like stable diffusion or use it as part of our application to generate images and stuff like that. So definitely learning a lot more about the technology in relation to generative AI. But the fundamentals are again, around reconstruction and being able to get back to an image that you'd previously not seen, really pulling together elements from different workflows.
Do certain kinds of models pose greater concern on an ethics front? So, I mean, artificial intelligence is so incredibly broad. It's like, okay, we have deep learning, we have neuromorphic computing, we have, federated learning, we have so much different stuff within it. So, do we worry more about one versus another?
It's a great question. And from all of the colleagues that I've spoken to, I think the consensus is yes. We do want to have hierarchies of prioritization and levels with which we use to decide what AI model needs to have more stringent ethical AI guardrails, we can put it as, compared to another. And that is really based off of risks and harms in terms of analyzing the ethical implications of the system on society. And then again, in and of itself, those methodologies and the definitions and frameworks that we use to figure that out, that's still under debate. If you use one metric or definition in order to, for example, identify fairness or bias of a system, you could accidentally, if you're optimizing for that fairness metric, accidentally exacerbate another. So you start to see, a lot of different metrics that you need to look at, some of which may not be relevant at all, and you have to tailor it accordingly. But putting aside those problems or, uprising concerns with the methodologies that we are working to solve, yes, there is definitely a prioritization level or a risk level. And I think personally, the European Commission's proposal on AI does a great job of doing the categorization. There's a lot more work and refinement to be done in terms of what is general purpose AI and what isn't. But having that delineation based on the use case of AI systems and how it builds up over time, that's definitely very useful. For example, AI being used for determining access to employment or to education is definitely has very, very big ethical implications and probably should be constrained very much. Whereas if we see the use case of AI in games or for like, Instagram filters, probably don't need that much of a constraint. AI in healthcare, we can start to think about the different obligations that we might need for chatbots or similar types of use cases. And definitely they have their own risks and harms associated with them. We want to treat them differently depending on the types of implications and harms that they can bring up.
What is the thing that you would worry about the most in this space?
I think think it may be not necessarily conflicting definitions and frameworks, but the applicability of of a lot of these methodologies, I think, may be a concern today, Camille. And I say this from the perspective that we have a lot of amazing teams across the industry, academia, governments, and so many different organizations that are now recognizing the problem. We understand that something needs to be done, and we are trying to handle it or attack it essentially from different phases of the AI lifecycle. There are a lot of tools out there. I think the objective right now is to evaluate what exactly each of us is adding to that space so that we're able to come up with some sort of a holistic solution. And I see that done as part of the traditional, computer science disciplines. And I think that is something that could definitely be reflected as part of AI ethics. And again, it's very nascent. It's going to take us some time to get to the place where we kind of currently are with AI. We have a sense of the different overarching disciplines within AI: reinforcement learning, supervised learning, unsupervised, right? We're able to categorize it fairly nicely. For responsible AI and AI ethics, we're just getting there. We know there's a lot that needs to be done. We have these principles like transparency, privacy, energy efficiency that we know something needs to be done about. But as the tooling ecosystem continues to grow, I think these conflicts and these overlaps are definitely going to iron themselves out.
I want to pick on one thing you said because I had a question about it and you just kind of articulated it perfectly. You said energy efficiency as a responsibility, which I think might allude to just greater sort of concerns for the planet or potentially sustainability, or people might call it climate awareness. How broad do ethics extend when we're talking about artificial intelligence? I mean, this is a compute tool. So how are we talking social movements? We're talking environmental.
It's a great question, and I think there are two questions hidden in that initial prompt. So, for the first one, in terms of the extent to which energy efficiency is, and like the overall societal context around this, and also kind of getting into the second question around how far is ethics really going into technology, my personal opinion is it's very far and overreaching, because when we are mentioning ethics, it is a very loaded and important term. And I think many of us in the AI ethics space, and myself included, we use that word in order to signify that there are implications for the greater context beyond just the technical mechanisms and the infrastructure we're creating towards explainability and privacy. For me, it represents that unification of the siloed elements where we are actually taking that into account, the bigger picture around, okay, societal debates that are surrounding the technology. For example, pulling on energy efficiency, definitely climate awareness is a key part of this. And to provide some context into this, there are two different main categories of AI and sustainability. There's sustainability for AI systems, where we're looking at optimizing AI models so they don't have such a large carbon footprint or are consuming less compute, etc. There's also the AI for sustainability, where we're seeing the rise of numerous different types of use cases for AI systems to help improve the climate, whether that's detection at a larger scale of trends and patterns, or even as simple as at a local level for users to better understand their footprint and what they can do to optimize or refine that. So within this, I believe that social aspect is very critical. It's why we need so many perspectives at the table. I often say it's like, I don't know, maybe 10 or more different disciplines and domains that are kind of integrating into this. At least that's what I've learned from all of the colleagues that are working in this space. So ethics is a very loaded term. It's a term that requires a lot of responsibility and a lot of different people. But again, that bigger picture always needs to, in my opinion, be there, even though we may, in a siloed way, work on technical mechanisms that enable each of the elements that are composing ethical AI.
With AI now tackling sort of, so like you say, greater social movements, is there a risk that there's kind of this consensus among, I'll just say, the tech community of what is social good or what is the right thing to do for the climate, and that does not represent the opinions of people who are maybe disagree, um, or don't have anything to do with technology and so aren't even following? Do you help me out here? Do you understand what I'm asking?
Yes, I do. It's a beautiful question because it is, in a sense, the answers to that can be somewhat controversial. But in my opinion, from what I've seen, to be completely honest, is when an AI engineer is starting to become a philosopher or is starting to get out of their domain, there's a lot of problems that can happen. It is a wonderful thing because a lot of the engineers who pathfinded and created the technology, they had a vision for where it should go. And I'm sure you may have seen, there's a lot of debate around founders of certain AI disciplines and the way that they wanted to see the technology progress. There's sometimes disapproval or disagreement with where it should have gone and where it is now. That speaks to the space of AI overall, with like the whole artificial general intelligence route. That's completely one way, and then there's also this route of deep learning and just building better models that are faster and more performant, sometimes large, sometimes small, and going that way. But throughout these different disciplines, there is, in a sense, a mixture of what you had shared. So the first is, we don't have a lot of team members who believe that the disciplines are important, but that is changing with responsible AI, because as soon as you mention ethics, that societal concept automatically comes in. And I've had many colleagues, they'll immediately bring up like trolley problem type of situations where you have autonomous vehicles, you want to decide what they're doing, or AI in the workforce, and there are very specific disciplines that come to mind to different teams of individuals as soon as you mention responsible AI. So I think that even the mention of it and the discussions are changing somewhat. The idea that technology is the only thing that we really matters. We're not really thinking about the broader picture. But when it comes to engineers or even specific teams, I'm also speaking to like legal and philosophy. If they don't have integrated disciplines or perspectives, definitely there is an amount of siloing. We don't get the type of alignment that we need. And we definitely see this as part of the regulatory conversations as well. If you have more representation of stakeholders as part of these committees that belong to one group over the other, you're going to start to see a couple of trends that are popping up. For example, if you have a lot of technical community members, you might find these definitions that may be hard to follow for lay people or for regulators. And if you have more of the regulatory folks that are involved as part of making standards or just guidelines and documents, you have things that don't have a lot of practical applicability back to AI models. For example, some of my colleagues have commented on this, saying, oh, there's a regulation out there that says this is what needs to be done at this point in time. But from the technical side, it really can't be done. You can't just make that statement. We don't even have the testing infrastructure to validate that statement is true if somebody makes it. So that type of discrepancy, we definitely need the different teams looking at it. So it's a balance. We need our teams thinking about other perspectives, but in the end, we need multidisciplinary teams, stakeholders, boards in order to attack the problems. So no one size, well, no one size fits all solution.
What are we doing about this data collection, massive asymmetry of information, those who are collecting the data? And a lot of times people become concerned that that is consolidated data collection and storage, even, and potentially access to held within some subset of corporations, actually, even not necessarily even governments, that don't yet have regulations or laws or policies, at least not global ones, in effect. So how should we look at that?
And I like the word that you used as well in terms of, the asymmetric kind of nature of the problem itself. So, as part of this, and it's very interesting, I think, to start this off by saying, there are specific instances even where, let's say, you did have access to unbiased data or you had access to the type of data you would need. You can also start to see label bias directly during the annotation stage itself, when you're cleaning your data, when you're removing outliers. And if something doesn't conform to the data scientist worldview and they take it out, or maybe it doesn't even work as part of their problem statement or analysis, it can have a lot of impact on other populations as well. Whether or not you're cleaning out missing data, again, stripping outliers from the data. Um, all of these data science operations, they can contribute to label bias and many other types of biases as well. But I think overall, when it comes to the data collection and annotation stage, it is a key problem in a number of different ways. And again, that have their own problem statements attached to them and potential solutions. For example, till date, all of the problems related to data sourcing have had solutions like, okay, can we use data augmentation? Do we use kind of the same data points that we have and then flip them around, turn them around, resize them, rotate them? Can we do something to change them up and then add them to our data set? And I want to take that as an example because I came across a very interesting case study or use case, a couple months ago that was illustrating something interesting here. So if we just plug into data augmentation for a moment, how could ethical AI influence this type of operation to potentially lead to better quality data sets, assuming that you don't have a lot of these available that you're able to find in the license that you'd like them to be in? So one of the examples that I saw is in a textual data set, being able to replace words that are gender specific to something that's gender neutral. And for me, although it seems like a very simple example, this tool was taking a look at doing it automatically and being able to create that nice data set, give you not a very detailed visualization, but some sort of a report out of what's going on and what were the changes as part of that were being made to the text. And I think that's just such an interesting example of how we can start to implement these types of concepts at lower levels that data scientists and AI engineers can use hands-on. If you don't have a lot of great data out there and you are forced to use data augmentation, maybe there are methodologies that you can incorporate at these levels that can help boost or at least enable some sense of data quality and ethical AI that are incorporated here, improve the diversity and representation of your data sets. So this is a poor example in the sense that, is that it? That's all we're going to do, just a quick fix to data augmentation. How do you know what impact it has on the system? But at each of these levels, we definitely need to have solutions. And my argument is maybe we start small and then we build up from there. And when it comes to data sets, being constrained to certain organizations, a very big problem because reproducibility has already been a severe problem in the data science space. When folks publish papers and models, sometimes they don't share their data sets. I'm guilty of doing the same because we don't have time, maybe. We don't want to go through a review process that's very lengthy because we want to get our results out there before someone else does. There are a lot of factors in there that can contribute to that. We do definitely need to see more data sharing efforts.
Can you just explain what data augmentation is? I'm getting that it means you don't have enough of one kind of representative within your data set, so you're maybe sort of multiplying or extending that to assume like there's more. You're making some kind of an assumption that may or may not be true.
Right. It's a great summary, but the first part of that premise is a little bit different. So, with data augmentation, rather than looking at, we are looking at representation, but not from the ethical AI perspective. So, for example, if you have your very typical SciFar or MNIST data set, if you don't, you want your model to perform better on fours or nines, or you just want to boost the size of the data set to 100 to 100,000 more samples or something like that, that's when you would start to apply these rotations, fixes, flips, resizing, basically to boost the size of your data set. In terms of data set augmentation for ethical AI, though, that's the nascent space.
So, what are the things that we're worried about with data augmentation with regard to ethics?
It's an interesting question. So, when it comes to data augmentation and ethics, there is one key problem that pops up all the time, which is, and this is the same problem that's exasperated or exacerbated with synthetic data. If you are generating additional data points for your data set, first of all, do they actually make sense? We do this all the time because we want to boost the amount of data because better data or larger data equals better models most of the time. It's starting to become the case where you can't always say that, but it's very gradually turning into that. But it's still, the equation is pretty much better data or larger data equals better models. So when we are kind of trying to boost the size of your data set and potentially in some cases even the quality, is it actually representative or reflective of the real world data when you're creating these samples for synthetic data, and data augmentation comes under synthetic data generation in many cases? Does it make sense? Are these the types of inputs and the trends that you would really see as part of the real world? That, I think, Camille, is the main question that comes into play with data augmentation. It starts very simple in terms of what is the real world applicability of the data, but then it starts to evolve into something that's a lot harder to tackle, which is when you are dealing with potentially sensitive data, and let's say you're generating data related to, a race or gender, or even, proxy variables, like, I don't know, not license plates necessarily, handwriting or something similar. It starts to evolve into something a lot harder than we can take.
So, would we do something like disclose the percentage of the data that was synthetic or augmented so that we could take some assessment of the risk of the assumption there?
Exactly. That is what we want to be able to do. And with that, we want to be able to track, that's why the provenance, and also validate the provenance of the image data. And as we can see, as we're having this conversation, we can start to think that, in addition to just having the percentage of the synthetic data in the training data set, or even, in the evaluation data set, wouldn't it be cool to have a little bit more information about
Which sets
how
of
the AI
data?
algorithm.
Which sets did you
Exactly, right,
augment?
right.
Yeah.
And then we run into security problems, which
Hmm.
is, okay, if there's a malicious actor who has a lot more information about the data samples that the model was trained on, because you're giving them information about the synthetic data, what couldn't they do with that information? They can engineer inputs that are matching that, or, they could try to play around with those inputs and see what happens. So it's so interesting. It's a lot to take, because when we, for example, present these types of fairness and bias, or even just basic representativeness, we're not really even talking about sensitive demographic data here. We're just talking about, does it actually match the real world? And then we immediately have our security teams that come up and say and raise these challenges as well. So it's a lot to take on for one person or one team, that's for sure. That's why we definitely need multiple teams that are challenging us when we say, oh, we have problems with our data set, let's use data augmentation. Okay, we have problems with data augmentation, let's use synthetic data. We have problems with ethical AI, let's use, like, change our gender neutral, or a gender, specific terms to gender neutral. We have problems with security, we put access control mechanisms, something like that. That type of workflow that needs to be established, we definitely need to do that. So
And it's kind of it almost goes back to the unintended consequences or unintended biases. Now we're sort of talking about another unintended scenario. While we're trying to fix one problem, we may be creating another.
exactly, right. And the weirdest part about all of this that I've seen so many different folks in the AI and AI ethics space raise is that AI systems are fairly, it's wrong to say that they're dumb, in the sense that if you put an AI model in an Internet of Things environment, you're empowering it, because it's able to consume all of the data that you're getting from sensing, and it is able to actuate in so many different ways, depending on how we structure it. But AI systems fail on, ridiculously strange real world inputs. Like, you can give it something that my team has personally experimented with this so many times. We'll give it an image of a cat in a blanket, like wrapped in a blanket, and it'll start to classify it as like a kite or a burrito. And this is one of the state of the art deep learning models, that has seen so many cats and dogs and blankets. It's trained on some of the largest databases, ImageNet and others, with like millions of images, but it just can't figure out these types of problems. And we see the same thing with autonomous cars as well, which is rapidly changing, I think, in the self-driving space. But there's always been, up until like last year, or even continuing to now, this question of, okay, we have a lot of self-driving cars out there, but how will they behave at like very busy intersections? But it's changing. We're seeing solutions pop up to that a lot. But AI models are still, fairly strange. They're weird, and we are already starting to see a lot of these capabilities pop up. So as we refine AI models outputs, because we do want to get AI models to a point where they are able to contribute to society with a better performance, we're going to start to see a lot of these issues increase. It's a strange kind of correlation, but it's true, because the better that AI models get, sometimes the worse the issues are. So that's something we need to handle.
I'd like to get your perspective on, because robots are now joining us in our homes and on the street. And I'd like to get your perspective on continual learning and the ethics around that.
I haven't been asked this before. So, continual learning is very interesting because it offers a lot of challenges, I believe. And this is also applicable for offline training, and a couple of conversations, very early stage, that I've been having with some of our Intel robotics teams as well, and externally, which is, when you're developing your model, you have access to a plethora of data. You have access to your ground truth labels. That's the main part of it, because that's how you're able to monitor the performance of your robot, your device, your AI model. You have access for this type of evaluation and training. When it comes to deployment, though, you don't have access to the ground truth, in the sense that you need to have this offline, human evaluation team, or maybe they're online, depending on the speed of the review. They're actually reviewing the AI model's outputs. They're checking what's going on. Maybe they're telling, okay, you did wrong here, you're doing right here. Rejection or accepting the outputs of the model, and they're providing that feedback back into the system. There are different models for doing it that way. That's the offline training way, but it applies for online training as well, or online learning, and continual learning, where you need to have at some point in time ground truth labels in order to assess the performance of the algorithms. There's something else that's added to this, which is qualitative behavior analysis, which is a term I'm just mentioning here right now. It's not an actual term, but just, if we take the example of a robot in a restaurant, if it's navigating over and it's bumping into a lot of tables, or it's just completely, bumping into a person as it's serving different folks, that's a problem. We're able to actually see that. Maybe our metrics that we've used, our quantitative metrics, are not capturing that. The performance of the model may be superb, but something's going wrong. Is it accuracy drift, or is the sensor damaged? What's going on with the model? So these two kind of quantitative and qualitative measures of evaluation are very interesting to consider. And ethical AI, we are hoping to actually bring from qualitative to quantitative. The reason why is the following. If, for example, and there's a great example of this with soap dispensers. I'm going to just take a tangent, but soap dispensers, computer vision based, no AI included. If they are dispensing soap for folks with a lighter skin tone compared to folks with a darker skin tone, there is an immediate problem that we start to see here. And we're seeing the same type of technology and biases reflected in AI models, for example, and this is just a generic example, that might be incorporated into robots and other applications as well. So you need to be able to perform that type of testing. And in the case of continual learning, you want some of this to be done real time, because you can't always tell the model, all right, pause, I want to do this test. You do want to do that, because at some point in time, you want to have a very thorough examination of what the model is doing and give it that performance feedback. But you can't do it real time and continual learning all the time. So you want some sort of a quantitative metric that you can anchor this on. And putting AI ethics into quantitative metrics, very challenging. That's why we boil it down to the individual elements and start from there.
What are the soap dispensers doing?
Oh yeah, so right now, well, essentially the soap dispensers are just dispensing soap, but what they're supposed to do is, if you've got a hand right, right underneath them, they're supposed to be able to just recognize that and dispense the soap. But in the case of, lighter skinned folks, they do it perfectly. It's all fine. In the case of darker skinned folks, it completely ignores them.
Oh, it's not seeing the hand or not
It's not
recognizing that there's a
recognizing
hand
them.
there? Oh.
Yeah, and a little bit more insight into this, at least from my current understanding, because if the I think the term used was like refraction, but essentially because of the light, they were not able to detect darker skinned folks' hands, and so they weren't. It wasn't like disposing it, no matter how much you wave it
Mhm.
around the dispenser. So it's a key problem. Definitely should be identified as part of your pre-design and development phases, not during deployment after you've released your
Mhm.
product and it's working in the real world. But I feel like that's a good example for AI models as well. You don't really anticipate these problems, but if you actually think about it, about benchmarking and evaluating on different groups of populations, then maybe you can catch some of these issues early on. But if it's the case like continual learning, you need to be able to do some of that real time.
Continual learning, maybe just give a very quick definition of what it is now that we've had the conversation about the implications.
Yeah, sure. So for me, the way I see it very simply is, what would happen if you could keep training for, maybe not forever, for a given duration of time, where the model is constantly consuming this data and it is able to predict and it's able to learn on the fly. And the different mechanisms that we would use in order to learn on the fly, they can vary based on the discipline. But that's the overall premise with continual learning. I think of it as, very simplistically, training that's being done over a very large time period, training forever. But yeah, that's the general gist of it.
Got it. So, are we ever going to see ethical implications flip on their head, and we as humans are going to have to worry about how we're treating machines? I'm
Yes,
okay. Say more.
absolutely.
I was not
Uh,
expecting you to say
I
yes to that.
Oh, it definitely, because it and I did end up writing a kind of a short thesis opinionated paper on this, and I got a couple of very interesting feedback
Oh, I'm
points
going to
on that
read
as
that
well, which
now. I
was
should have already read it,
oh,
but
thank you. Oh, no problem. I'll provide the summary here because it's just so interesting. So there was a initial research experiment. I forget when, but it was a couple of years ago where there were these researchers who created a robot in a mall that was supposed to do some navigation. And they encountered, in my opinion, what I like to phrase it as like an unanticipated concern or an unconventional concern, where they had a lot of kids that were trying to kick the robot, punch it, move it around, shift it. Some of them were curious, some of them were violent. So they had to deal with this newer problem. So what the researchers did, they built a attack estimation, I believe if I recall this correctly, an attack estimation algorithm and also a trajectory planning algorithm so that they were able to avoid kids that were coming their way and trying to attack them and either maneuver to the parents who were taller, so they were judging based on height or maneuver somewhere else. So it's interesting. I believe they called it like an attack evasion model. So it's interesting because it raises a lot of questions around how do humans act with AI systems. And one of my peers in this space was also telling me, based on a recent study and a survey that they were working on, that a lot of us users of AI technology, we do want to design our actions or the way that we act in a way that helps AI systems. Again, it depends on the types of communities that you're surveying as well. But the majority, we want AI to work, and we're willing to change somewhat in simple ways the way that we help AI systems. And let me provide an example of that. For example, if we have an AI system that is helping us in a healthcare setting to report that we've taken our medications or do some sort of processing there. If it's just as simple as angling your medication bottle a certain way, or or doing something, maybe turning on the light. I think we're willing to do that to help the AI algorithm better detect it. And when it comes to that, we start to get some expectations as users. It'd be nice to have a little manual that tells us, how can what is this AI model doing? Where does it, typically fail? So that's one thing that we might want to see some information on. And again, we may also want to figure out, okay, how do we actually use the system? Where is my data going with the system? We have a set of requirements and expectations that we want to know. What exactly is this model doing? Same thing with an interactive kiosk. If it's taking my voice commands and it's using that information, it would be great to know where exactly is that going to be used. Is it going to be used against me? We need to answer these types of questions and preferably real time. So that's why I think definitely we need to think about the way that humans interact with AI systems and the ethical implications towards AI systems. Maybe not because AI has consciousness and emotions, which is a debate in and of itself, but I personally believe we're not near that. But because the effect that we have on AI systems are amplifiers. So, in general, we're impacting the people around us and the people who are trusting AI systems by being untrustworthy towards AI.
Right. Well, I know you brought it up. So now I do want to ask you your opinion about machine consciousness because it's such a debate right now. We're nowhere close. So, in your opinion, what would it take to know that we are close? Or could there ever be a scenario where we were close to that?
I believe the consensus is we are not close to machine consciousness when it comes to a timeline. If we were to get to that point, it's probably not going to happen in the sense that you can get some sort of a simulation or of a model of it. And I know quite a few people in the philosophy space who sometimes argue that we even can't get to that type of approximation, which is a good point. And I definitely take their word because they're the experts in terms of what really is consciousness. But personally, I believe that we can get to some sort of a simulation or modeling. And the reason why I say this is if we're able to create maps of different human emotions or morality, which is work in progress, different ways that humans react in different situations, we can get to simulations of emotion. We see it a little bit today in chatbots, where actually, if you look at the technical advancements in chatbot technology, they're really targeted around how do you best respond to phrases like, hey, how was your day? Rather than sounding robotic in a sense, actually having that type of a nice little interaction. So I believe we're going to get to simulations of it. We're not going to get to possibly the consciousness or maybe the thought uploading, but you never know. So I'm totally open to the prospect of things changing over time. But when it comes to extended consciousness as a whole, I do definitely see AI as an enabler or an amplifier or some sort of a process that you can use to, from a philosophical standpoint, kind of extend your extended mind. And this actually takes me back to a great point that Pat made during the Innovation 2022 keynote, which was that everything is a computer. And that is very interesting to think about because in a sense that, everything around you is a device that you can use and that computes or something like that. So for me, I see AI as kind of an enabler and amplifier of that. And it goes back to the original research on the extended mind and other stuff from the philosophy space. So we'll see. For now, short answer, probably not around machine consciousness, but I'm open to the possibilities and I'm not biased towards it. So we'll see what happens.
How do you see it as extending an extension of consciousness?
Based on the definitions of this, I mean, the way that we currently interact with AI systems is, can you get this task done for me? Or, can you listen to my command? And I'm thinking of voice recognition or assistance. I've got my phone right next to me. If I'm telling Siri, please send me this, send out this email or something like that, that's the extent to which we have it today. But as we start to see more human-centered AI systems like robots and others that are interacting more closely, for example, robots that are interacting with the elderly, we're starting to see a lot more emotions and connections that are being created there. And eventually, I feel like we may start to see AI agents that are really improving productivity by being this type of second backup that you can rely on. We're seeing it slowly, not there yet, but for example, with generative AI, this content creating machine that generates really weird images and text, but something that you could use as part of your creative process, right? That kind of backup thought generator or something like that. So I feel like as part of that, it's really adding to the thoughts or, the persona that we currently are. Maybe it's, for example, personalizing our feed of the clothes that we're buying and the food that we're eating. So it is adding to who we are as a whole at individual and group and societal levels. So from that perspective, yes, I believe it can kind of extend our consciousness. Again, depends on the definition, but yeah.
Do you think, I'm going to try to make this my last question. It's incredibly difficult to hang up with you. um, so you're 18, so this is relatively young in the scheme of humans. What do you think? And the other day, the Intel CEO said you'd be CEO in 30 years. So I guess in that kind of a time horizon, if you can think forward, if time moves linearly, um, what do you think we'll look back on from this time and say, oh my God, we were such babies in this space, or we didn't see, or we moved, we stepped left and we should have been thinking about right, like as humanity dealing with artificial intelligence and its rise.
I think we shouldn't because we tried our best, and that is definitely reflected in the current attempts that we have. And the reason why I say this, Camille, as well, going back to kind of those controversial debates around, what was AI planned to be and what has it come to now? I think it may be, it's not an incorrect question to ask. Opinions are always welcome about this, but from what I see today with AI and technology, we've tried our best and ventured into so many different domains. So I know that when we get to the future, we're going to converge to something that's amazing. We're going to get to technology that we probably had not even thought about before. But all of these directions had definitely led up to this. All of the thinking, the failures, they are building up to this. Now, there is an element in here that I think is that doesn't apply to, or this type of optimistic point of view doesn't apply to, and that is ethical problems. So, for example, if we're seeing the introduction of facial recognition into, challenging environments or use cases in the sense that it just doesn't set right morally to see certain applications introduced to many of us, not just at an individual level, but we're actually seeing that at a shared level. That's something we do want to be able to prevent ahead of time. And again, to be completely transparent, I'll mention it directly. One of the key debates here is around, do we ban facial recognition altogether or do we keep it? And there's folks on many sides of the arguments as well. We all see the potential for it, but we all see the capabilities for destruction as well. So I think having conversations about that early on and definitely acting based on those conversations, that is what we definitely need to do. I don't see it as something we'll regret in the future because again, we have multiple teams and different folks that are working on it, talking about it and raising it. But it is something that we do need to get alarmed about and get alerted to. And I think all of us are again working towards that type of outcome. So I'm very optimistic for the future. I'm happy. I know that we're going to be able to solve it. And yeah, we're working on it. So
Well, Ria, thank you so much. It's Ria Cheruvu, who is AI ethics lead architect at Intel, and just very recently on stage with Intel CEO Pat Gelsinger, talking about Gaudi and other AI chips. I don't know if there's anything you want to say about Gaudi.
about Gaudi, oh, it's a fantastic technology. And I do want to say it was an honor to share the stage with Pat and to demonstrate some of the wonderful technologies out there. Getty, Gaudi, and our Intel Scotland's team's amazing work to get the optical innovations out there, and a ton of other work with OpenVINO, with game development as well. So it's definitely the challenges that we face today. We're going to continue to face those from an AI perspective, but AI quality and a lot of these other key capabilities and performance related items that we're looking at when it comes to technology, we're solving it. So I'm very, very excited for the future and what we're going to do.
Thanks again, Ria. Appreciate it.
Thank you, Camille. It was wonderful speaking with you.
Thanks for joining us for Cybersecurity Inside. You can find more episodes, including our companion series, What That Means with Camille, wherever you get your podcasts.
The views and opinions expressed are those of the guests and author and do not necessarily reflect the official policy or position of Intel Corporation.